This is Yashaswini Razdan reporting for EE Times, and I'm sitting here with Gilles Garcia, who's the Senior Director Business Lead, Wired and Wireless Group for AMD. Hello, Gilles.
Hello.
Nice to have you.
Thank you to have me here.
Gilles, so AI has been in the cloud for years. What is changing about AI now that, it's moving into physical systems, it's moving into robots and industrial design. So what's changing over there with AI?
So let me put some context first in this. So what we have seen in the past probably 10 years is a lot of talk about AI in the cloud. And so for that, AMD has a very strong portfolio. And again, in our booth, we have the Helios, which is a solution rack. So exaflop capable with 72 GPUs, a beauty beast. You have to go there, it's a beauty beast, which is dedicated for the cloud AI. But then, when you are thinking about cloud AI, you are thinking, where do I need to be in the edge or far edge if I want to be able to address some new application, new use cases that will require low latency, that will require immediate actions, or that could not require to go back to the cloud. So, for example, robots will be one, but I want to give you the context of this industry. We are seeing in every industry, we are always seeing the thing starting from the cloud and moving to the edge. When I was young, everything was mainframe from IBM in the cloud, and suddenly things moved down with the laptop, the PCs, to the far edge. We are starting to see exactly the same thing with AI, meaning that the big generative AI and the big models that are very complex, that require a lot of compute, require the cloud. But models that can be complex but that require much less interactions with the cloud could be done at the edge and far edge. And autonomous automotive can be one, industrial robotics, healthcare, autonomous networks will be those type of applications that will require to have physical AI implemented.
What is the essential difference between physical AI and edge AI? Are they the same, or is there some sort of difference?
So it could be the same and different, because it depends where is the edge. Because when you are talking about edge AI, you can be talking about far edge AI as well. So it's all depending about, first of all, what is the use case that you are talking about? Robots could be at the edge as well. But if you are, because then you can have a large industrial plant that could be a very large manufacturing that will be considered as an edge compute systems. But all the robots within this plant will be considered as physical AI. Because they will need less compute than what an edge data center will need. They will need less power consumed or to dissipate, because they will not be able to dissipate more than 20, 50 watts per applications. They will have different requirements in terms of latency and reaction. If you want to have a human robot or humanoid robot being able to interact with human, this needs to be at the speed that the human are used to interact. If you want to talk about industrial robotics, it will be even faster reaction that we need, because they need to have a very high cadence of production, and you need them to be able to detect good parts, bad parts, or to do different applications very, very quickly.
Understood.
So the same technology could be potentially used, the same models could be used, but at different scale between physical AI and edge AI.
So this change that we are navigating towards, this change towards physical AI, who is essentially driving this change? Is it the end consumer, or is it the rapid innovation, the engineers?
So all of the above. In fact, but we need to be careful.
Somebody, is it the vendors they are pushing for it and telling the customers that no, you need to adopt this?
AI, it's a big transformation.
Yes.
And it's not only a technical transformation, it's a human life transformation. Again, ChatGPT, Gemini, all those generative AI models are suddenly making making the people getting access to answers fast that they were not getting before. But this is just one aspect of the AI. If you're thinking about AI still on the cloud, how to accelerate discovery of cure for medicines aspect, that's a different aspect. I think that AI, and it's a big transformation for human life. And we need, as a vendor, true that we need to enable human beings to have access to AI, but that can be wearable or that can be touchable by the people. So it's not a vendor decision, it's more where do you need to have AI to make the transformation of the life of the human life. And if this is too far from the people like you and I, then we will say, oh, that's not for us. We will keep continuing just ChatGPT something and not acting on AI by ourselves. I want to be able to have soon glasses that I will be able to discuss with you in Indian or in the local language if I'm going anywhere. I don't want suddenly to have to type this on my iPhone to get back and forth with the thing. So for me, it's a life transformation that we're going through. Enabling people to do things or support people when they have healthcare issues, or accelerating the build in the industry, or accelerating autonomous cars, and safely and reliably, that we need to push those AI capabilities to the edge and to the far edge.
Interesting. So which industries do you see are moving the fastest towards adopting this AI transformation?
So, first of all, let me just answer one more thing. I believe that AMD is leading the change on the physical AI. And one of the reasons why is the portfolio that we have today. And that will be the transition to your question, is we have been working on the past 20 years already with the industrial 1.0, 2.0, 3.0, and 4.0, meaning that we have been already in a lot of robots with the previous technology that was looking at vision transformers, being able to recognize the object, but not taking decision locally, having to report the things to somewhere else. Now, we are helping the transition for the industrial, as an example, and this is one of the lead, by the way, things that we are seeing, and I will talk about the robots, the humanoid robots in a minute. We are seeing the industrial robotics as one clear leader in the physical AI.
Okay.
Because they want to accelerate the autonomous capabilities of the robots in the plant.
Okay.
To have better production, better, more efficient and faster production, but also to have less human requirement around to check on quality or to check on security. They want to be autonomous from a security, reliability, and flexibility to be able to change the line of the production from, I will take an example, from an iron to suddenly fabric something that would be for the automotive industry. So they want to have this flexibility, and only local AI will allow them to have those type of flexibility. If now you're talking about humanoid robots, again, we have all seen movies with those robots that are conversing with the people. We are almost there. We believe that in the next 10 years, the humanoid robotics will probably be the biggest transformation to support the people and help the people. From the elderly care, from the hospital, taking care about the patients. So all the things will evolve completely with the AI. But in order to do so, you need to have those AI models being able to run into very low power, potentially battery life used technology systems, to be able to be closer to the human being.
Why do you consistently insist on making it local? Why can't these physical AI systems rely on the cloud?
Because let me take an example is India. If you want to have in a village or even in Delhi, you are in the suburb of Delhi, you have a robot. You want the robot to take actions. Will we wait a few seconds that the robot is sending the information to the local data center that could be in Bangalore or somewhere else in India, make the processing and then go back with the answer? your robot will be useless. The robot need to be able to take actions based on perception, sensing, touching, vision, and being able to act immediately on what is required to do so. And same thing for the humanoid robot, same thing for the industrial. All the sensing, touching, vision, and perceptions will be taken care by the AI. Compared to a single camera, which is only doing visual, the camera will be able to sense, will be able to percept, and to then react immediately to what it would have been trained for.
Coming back to what you said, physical AI needs to be, the devices needs to be essentially they should be able to run on low power devices. Now that you've mentioned, you yourself said that a lot of processing, compute is gonna happen at the edge. So do we have those devices which can handle such massive compute at essentially very, very low power?
So yes, and that's the beauty of already what we have been working with AMD as part of AMD for the last 15 to 20 years. Today, as part of the embedded group at AMD, which is driving the physical AI, we have been in cameras, surveillance camera, sensing cameras, robots for the past 15 years already. So we have a lot of experience on what is required. Now, with the technology that AMD has, we can have 5 watt, 10 watt, 15 watt devices that can fit in different systems at the end, which could be a humanoid robot, and that will be 10 to 50 watts. That could be a camera, and it will be sub 5 watt type of capability. That will be able to run models. Because I think that people need to realize that it's not because you have a large model to run. Large does not mean that you need to have GPUs.
Yes.
Large means that it's complex and that you need to have very efficient technology to run those models. Let me give you an example. Very often when you're discussing with people, when they are hearing, oh, I'm running a Llama 3.2 billion parameters, they're saying, wow, how many GPUs that you need? To run a Llama 3.2 1 billion parameter model, we need, at AMD, we need a sub 25 watt device. Meaning that the complexity of a Llama 3.2 1 billion parameter can be run into a very efficient small device that can fit into a humanoid, into a robot, into a car, into all those physical AI systems that will be, and so we are enabling with the high technology, the different models that will be used. Not to say that we'll have Llama 3.2 everywhere, but this is to show you the complexity of the models that we can run in very efficient and low power technology.
When in your engagements with customers, what do customers want? Do they want performance? What do they prioritize? Performance, or do they prioritize thermal efficiency?
So for the physical AI, one of the first questions is power.
Okay.
Because you are not plugged all the time. Your robot, again, taking again the example of a robot or in the industry, it's not plugged every time. So you need to have it being able to do a battery life sustainable. So that's the first thing. Second thing is definitely performance, meaning the performance per watt is really what the people are looking for. Is what is the compute that you are able to do to run models in a certain power envelope that, first of all, I can dissipate because you don't want your robots, whatever it is, to be too hot, but you want being able to sustain a large number of hours that you can still interact in the industry, in the plant, or at home, or in the automotive, in the car, or in the autonomous truck, or in the networks. Because we are seeing all those locations requiring those low power, high compute capabilities. And last but not least is latency. Because latency, you need to be able to react and act very rapidly without having to wait for even milliseconds or seconds to act on something, because sometimes it could be life-threatening.
You have also got an embedded Ryzen AI product that is there. What role does it play in this, transition from towards physical AI?
So it's one of the cornerstone. It's one of the first built-in product, the P100 that we announced, which has been built for the physical AI. meaning that he has a compute capability, a small GPU, and when I say GPU, it's not to compare with the Instinct or other big GPUs, it's a purpose-built GPU to be very efficient for the physical AI. And so it's getting at the right capacity of compute and power capabilities that it can fit into those different use cases that I mentioned. So you have to see this new Ryzen P100 as a heterogeneous compute capability with x86 compute capabilities, GPU capabilities, NPU capabilities. And so it's almost all in one. We are using the best of breed technology reduced in terms of size compared to the Helios rack that we have, but that will still be answering the 10 tops to 400 tops teraflop of operations that the physical AI required in the far edge of those applications.
But why are you combining CPU, GPU, NPU? Why not use just a AI chip?
Because again, you need to have every GPU need to have some software running, and most of the time it's running into x86.
Yes.
So here what we are doing, we are combining all of them to have a low power device with all-in-one. It's like you don't need, if you want to be autonomous in the robot, you need to be able to have the vision capability, the touching capability, and those require different pieces of technology and software to run. Some will be more CPU friendly. Some will be running into a GPU AI capable system, some others into NPU to get the connectivity to the which could be Wi-Fi or vision or camera sensing information.
What kind, so could you help me differentiate what kind of workloads would run on an NPU versus what kind of workloads would run on the CPU?
So I would say it's not depending on the workload, it's depending on what is the performance that you want to achieve.
Okay.
So some workloads will be running in both the GPU and the CPU.
Exactly.
And so because the CPU is very good to do some tasks of compute, where the GPU will be very good to do some DSP-based type of application.
Yes, yes.
So it's more a capability to offer that you can have a mixed model that will use the best of the model and the most efficient way to deliver the functionality. Codecs, if you have a vision capability, codecs will be required, and the codecs will be using hard blocks within the GPU to do that.
Okay.
For example. So it's really making sure that we can answer to what is the best technology to run what, where.
When customers speak to you, do they ask for flexibility, or are they looking for, fixed function acceleration?
No. Fixed function does not exist in AI. The reason why is because in fact, we know what we know today on AI, but 6 months ago, we did not know what will happen today in the AI, and we don't know what will happen in 6 months. So the flexibility is critical on the AI technology. So for example, we have been shipping within AMD a device with AI engine capability since 5 years. 5 years ago, we did not know what it will be used for. We knew what it will be used for at the time we ship it, but we are seeing customers using it on complete different applications that we were thinking it will be used for 5 years ago. So flexibility is critical because, first of all, customers can be able to run different models over time, can be adding models in parallel with models. We are demonstrating on the AMD booth a device on which you can run different models to address different applications, which could be a vision transformer. You can address a different automotive use case, because at the end, customers want to be able to either run several models in parallel because they will have different use case to run, or they want to be able to scale up or scale down their models depending of the applications or depending of the location.
You mentioned x86 is still being used. Everybody, and it's a very good processor. Why does it still make sense in embedded systems, industrial AI systems? What is so special about these systems?
So industrial, they need the characteristics of this role is several things. Connectivity is one, because you need to talk to something. Is it a Wi-Fi network? Is it an Ethernet network? You need to interact with what is around. The x86 will be very good to manage those interactions, meaning that if you want to have industrial plants, very often the robots will have to understand what the other robot is doing. And so x86 can be a perfect AI automation type of system. But you will need as well, within those robots or industry robots, to have things that are specific for vision recognition, perceptions, sensing, that will then require special AI acceleration. That could be a GPU or that could be other.
Exactly.
But then putting them all into the same device, for us, it's allowing us to to offer a single device that will be able to cover the complete systems that the robots will require, covering from the sensing, the touching, the perceptions, and the training and inferencing itself, so he understands how to interact with the other robots around him, or with what's going on around the robots.
There are many approaches to edge AI. You mentioned we have GPU heavy platforms. We also have ARM-based SoCs. A lot of companies in India are doing that. What is AMD's biggest differentiation?
So first of all, it's one size does not fit all.
Yeah.
Meaning that our portfolio, from GPUs for the cloud to physical AI devices, can scale and can be used wherever it makes sense. Because one model is not equivalent to the other models. So what will run into your autonomous car will not be the same model that will run in the humanoid robots, or what will run in the industrial robot, or what will run into the networks AI. So we need to have a very flexible and very scalable platform. So that's one of the key differentiation that we have. But the other thing is, we have the overarching software. We are open, meaning that we are an open system company. All those devices that I mentioned, from the GPUs, large GPUs, to the CPU, to the physical AI, are using open source and are open to software open source activities. So we want, and we are creating an ecosystem for the people to deliver the right model or the right application with the right technology that will consume the right power, performance, and latency for what they are looking for. And one size does not fit all, but AI is everywhere.
Talking about the future, do you think today's NPUs have enough room for future AI expansion, AI models?
I would say that today, the technology that we have can answer to a lot of the requirements that we know for now and the next several years. Now, AMD is continuing to invest and will continue to have roadmap evolution and technology evolution to answer new requirements and potentially new compute cases that will be happening in the next few years. Because, like we say, we know what we know what will be required for the next few years, but we don't know if there is a new application that will be an inflection point. So for that, we still need to continue to innovate. And AMD is probably the best innovation company that exists in the industry.
What is the bigger challenge? Is it compute performance or is it system integration?
So it's a hard choice, because to have the right system at the end, you need to have the right technology, but you need to have the right system integration to deliver the use case at the level that the end user is saying. So it's hard to say, because you need all the above to deliver toward the expectation at the end. So that's why for us, we are developing the technology. We are working with large system integrators or small system integrators to deliver the technology into a system. When we are taking the Helios, for example, the big racks that we are showing here, we have decided to take on the complete integration, so that we are providing a reference design that others can take and customize or tailor toward their needs. When for a GPU, the customer can also buy a GPU, what we're calling a chip down, and then work with local companies to deliver their GPU clusters. And in India, we have several partners that are building their own GPU clusters based on the AMD technology. So system integration is key to be able to answer the use cases or the verticals. Because AMD, we are not a vertical company. We are a technology provider and a AI solution provider, but we need those vertical system integrators to deliver this technology with the layer of software or customization that will be fitting the vertical which is targeted for.
My final question, if physical AI becomes mainstream in the next how many years, I cannot predict. But if it does, what will change what will change first? Will it be the silicon? Will it be the stack? Or will it be the business model?
I think that, so I will start by the business model. I believe that the physical AI, we open up a complete new business model for startups, industries, and companies, because they will be able to offer new services that was not possible before. But in order to be able to sustain the business expectation, and business can be changing the life of the people in the good way, we need to continue to innovate. And so it's not who is coming first, it's who is going together to innovate, but have innovation that will be really transforming into a business opportunity for the people, for the startups, or for the companies, or for the individuals to then use this technology. Because we cannot force, as an industry, somebody to use AI. We need to make it so integrated into what the people are doing every day, or serving them every day, that it will be a natural evolution, that those people will start using AI and will then start doing potentially new business opportunities and new business models with AI.
All right, that's been a very enlightening conversation. Thank you so much, Gilles, for being here with me.
Hello, my pleasure.
Thank you.
Thank you.